The power of volcanoes, eruptions, heat, and formation. Volcanoes are some of Earth's most dynamic and powerful natural phenomena, shaping the planet's surface for millions of years. From the molten lava flowing down the slopes of Mount Kilauea in Hawaii to the violent eruptions of Mount Vesuvius in Italy, these geological structures have fascinated humans and reshaped landscapes. But what exactly are volcanoes, how do they form, and just how hot do they get? What is a volcano? A volcano is a rupture in Earth's crust where molten rock, gases, and volcanic ash escape to the surface. The word volcano derives from Vulcan, the Roman god of fire, symbolizing the intense heat and destructive energy that comes from deep beneath the Earth's surface. They can be found both on land and under the ocean, where tectonic plates either collide or pull apart, allowing magma from the mantle to push through. There are three main types of volcanoes: shield volcanoes, stratovolcanoes, and cinder cone volcanoes. Shield volcanoes, like Mauna Loa in Hawaii, are broad and dome-shaped, created by lava flows that spread over wide areas. Stratovolcanoes, such as Mount Fuji in Japan, are steep, symmetrical cones formed from alternating layers of lava, ash, and volcanic rock. Cinder cone volcanoes are smaller and have steeper sides, often formed from single, short-lived eruptions, like Paracutin in Mexico. How do volcanoes form? Volcanoes are the result of geological processes deep within the Earth. The Earth's crust is divided into several massive slabs called tectonic plates. These plates are in constant motion, floating on the semi-fluid asthenosphere beneath them. When these plates interact, through collisions sliding past one another, or pulling apart, volcanic activity can occur. Subduction zones. In areas where one tectonic plate is forced under another, a process called subduction, the descending plate melts due to intense heat and pressure. This molten rock, or magma, rises to the surface, leading to volcanic eruptions. This process explains the formation of many of the world's volcanoes, particularly those found along the Pacific Ring of Fire, which encircles the Pacific Ocean and is home to about 75% of the Earth's active volcanoes. Divergent boundaries. Volcanoes can also form along divergent plate boundaries, where two tectonic plates move apart from each other. In these regions, magma from the mantle rises to fill the gap, creating new crust as it cools. The Mid-Atlantic Ridge is an example of this, where volcanic activity has continuously built up a chain of undersea mountains. Hotspots. Some volcanoes form far from plate boundaries in areas known as hotspots. Hotspots are regions where plumes of superheated material from deep within the mantle rise toward the Earth's crust, causing volcanic eruptions. The Hawaiian Islands are a classic example of a hotspot chain, where the Pacific Plate moves over a stationary plume of magma, creating a series of volcanoes. Volcanic eruptions. Volcanic eruptions vary greatly in size, intensity, and impact. Some eruptions are quiet, with lava flowing steadily from the crater, while others are explosive, sending ash, gas, and pyroclastic flows, a fast-moving current of hot gas and volcanic material, into the atmosphere. The type of eruption depends largely on the composition of the magma and the amount of pressure that builds up inside the volcano. Effusive eruptions. These eruptions involve the steady flow of low-viscosity lava that can travel long distances. Effusive eruptions, like those seen in Hawaii, tend to be less violent and more predictable. The lava flows cool and harden, creating new land in the process. Explosive eruptions. These eruptions are far more violent and dangerous, often caused by gas-rich, high-viscosity magma. When this type of magma reaches the surface, the trapped gases expand rapidly, causing the volcano to explode with tremendous force. Explosive eruptions can eject large amounts of ash and volcanic rock into the atmosphere, posing risks to nearby communities. The eruption of Mount St. Helens in 1980 is a famous example, which resulted in widespread devastation, killing 57 people and flattening thousands of acres of forest. Volcanic ash and pyroclastic flows. One of the deadliest aspects of an explosive eruption is the release of pyroclastic flows, superheated clouds of gas, ash, and volcanic rock that can travel at speeds of over 700 kilometers per hour, 450 miles per hour. These flows are incredibly destructive, obliterating everything in their path. Volcanic ash, though less immediately dangerous, can also cause long-term damage, disrupting air travel, agriculture, and human health. How hot is a volcano? The heat inside a volcano is immense. Magma, the molten rock beneath the Earth's surface, can reach temperatures of 700 degrees Celsius to 1,200 degrees Celsius, 1,300 degrees Fahrenheit to 2,200 degrees Fahrenheit. When magma erupts as lava, it remains incredibly hot, though it cools as it flows away from the eruption site. The hottest types of lava, called basaltic lava, can maintain temperatures near 1,200 degrees Celsius, 2,200 degrees Fahrenheit, while cooler, more viscous lava, such as rhyolitic lava, flows at around 700 degrees Celsius, 1,300 degrees Fahrenheit. Volcanic gases, which include water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide, also reach extreme temperatures. These gases are often expelled during an eruption, creating steam clouds or contributing to the formation of acid rain. The global impact of volcanic eruptions. Volcanic eruptions can have far-reaching consequences, not just for local communities, but for the entire planet. Large eruptions can send ash and gases high into the atmosphere, affecting climate and weather patterns. For example, the 1815 eruption of Mount Tambora in Indonesia caused what is known as the year without a summer, when global temperatures dropped due to the immense amount of ash and sulfur dioxide released into the atmosphere, leading to crop failures and food shortages. In recent years, scientists have also become increasingly aware of the role that volcanic activity plays in the Earth's long-term climate cycle. Volcanic eruptions can contribute to both global cooling and warming, depending on the volume and type of gases emitted. While volcanic eruptions are not frequent enough to cause permanent climate shifts on their own, they are an important part of the Earth's complex climate system. Conclusion. Volcanoes are awe-inspiring geological features that reveal the raw power of our planet. From their fiery eruptions to their ability to create new landforms, volcanoes remind us of the dynamic forces at work beneath the Earth's surface. The process of their formation, rooted in the movement of tectonic plates and the rise of molten magma, is a testament to Earth's ever-changing nature. Though potentially destructive, volcanic eruptions have shaped human history and landscapes in dramatic ways. Their intense heat, capable of melting rock, serves as a reminder of the incredible energy stored deep within our planet. As we continue to study and monitor volcanic activity, we gain a deeper understanding of these fascinating natural wonders and their role in shaping our